Okay, so we're continuing dealing with polynomial fractions. So in other words, we have a fraction with a numerator and denominator that is a polynomial, not a monomial, which is what we've dealt with before. These are slightly more complicated problems. They are going to require you to, what's the F word?
Factor.
Factor, that's right, factor. All right, so here we go. So in question E, we have a numerator and denominator. We're going to have to factor them both. So how are we going to factor the numerator?
5.
What? 5 goes into both of them? There's a typo?
Yeah, it's on F. It's 3x squared. Or it's 3x to the third.
We'll get to that. So we have 5 goes into both of them, right? So we're going to have in the numerator 5 times, and what's the quantity going to be?
3c
plus 5d.
Okay, questions so far?
Wait, can you still?
All right. So we're going to have to factor the denominator. Does the denominator share any common terms?
Yes.
What?
10.
10 goes into both of them. Okay. So let's factor out a 10 from both of them. So we end up with 10 times the quantity. What's going to be inside the
9 squared.
9c
Minus
squared? Oh, that's
25d
interesting.
squared.
That is a perfect square, isn't it?
Yeah, it is.
Minus what?
25d squared.
Oh my goodness, that is a perfect square as well.
Perfect square.
So, and it's a subtraction. So what does that mean the denominator is? It's a difference of squares. So we're going to have to factor the denominator again. So I'm going to have my fraction bar. We're still going to have the numerator. That hasn't changed. And so in the denominator, we still have the 10. How do you factor a difference of squares?
You gotta do the plus.
We have a plus and minus. So since you said plus and a minus, I'm going to go out on a limb and say we're going to have a pair of binomials. We have a plus, we have a minus. What goes here?
3.
3.
Oh, shoot. Sorry, that's 3. So we have 3c plus 5d. What goes in the other? What goes in the other binomial?
3c minus 5d.
3c minus 5d. Okay, so I'm going to clean this up a little bit from my mistake right here.
For the viewers.
All right. So that was, in fact, a, come on. So we had 3c here. Now, do we have any common terms that can be canceled out?
3c
Yeah,
plus
we got
5d.
3c plus 5d.
All right, we have a 3c plus 5d here. We have a 3c plus 5d here. Do we have anything else we can cancel out?
No.
Oh, I'm not sure about that.
5 and 10.
5 and 10 share a factor of 2. So, well, they don't share a factor of 2, but,
1 and 2.
oh, because 5 goes into 10 also?
Yeah, it's a half.
Okay, so 5 goes into 5 once, 5 goes into 10 twice. So what ends up in our numerator?
1.
1. Because 5 has canceled down to 1. 3c plus 5d has been canceled to 1. And 1 times 1 is 1. Okay. What's in our denominator?
2
parentheses 3c minus 5d.
5d.
So that's really just, do you even need that? Can it just, never mind.
You need to have the fraction because that is in the denominator. You're right. So there we have it. So this problem was marginally more difficult. However, it didn't ask us to do anything we haven't already done, which is nice. So let's take a look at f. So for f, again, we're going to have to factor. Now, do we need to factor the denominator? Do we need to factor? Oh, yes, Ava is reminding me that this should be to the third power, right? Okay, so I can check.
What's the denominator?
All right.
Yeah, the denominator should be.
The denominator should be to the third power. Okay.
That is a cool toy.
All right, so there never was a typo ever. Okay, so I do need to factor the numerator because it is a polynomial. So what goes into 3x squared and 6x? X and 3. X and 3. So we know that 3x can be factored out. So what is 3x squared divided by 3x? Just
minus 2.
X minus 2. You see, you've already jumped ahead of me. And this is all over 3x to the third. Okay. Do I have any common terms that can be factored out?
No.
Stella?
Actually, wait, can you cross out the x? Oh, never mind.
I will be crossing out some x's, but
Can you cross out the x and one of the x's in the 3x?
yeah, absolutely. So x divided by x to the third is going to be 1 over x squared. Okay.
Wait, can you?
Yeah,
and
'cause
then would you cross out the other x? Like, or the
No,
oh,
that's
the
one.
3.
The 3 divided by 3 is 1. So we are left with x plus 2 over x
Minus.
squared. Oh, sorry, minus. Thank you. Now here's the thing. A lot of students will be tempted to say, oh, this is x squared, that's x, I can cancel these out.
Because that's one whole term.
But that is not true because this is one whole term. You would have to be able to you'd have to be able to divide x by x squared, and you'd have to be able to divide 2 by x squared. Can 2 be divided by x squared evenly?
No.
No. So there's nothing more that you can do with this. By the way, x cannot equal 0. It can't equal 0 because 0 squared is 0. So there you have it. Okay. All right. Moving on to G. All right. So we have a numerator and denominator that are both trinomials, and they need to be factored as trinomials so that we can find common factors that we can cancel out. So which, the numerator or the denominator, which of those two is going to be easier to factor?
The x. Oh.
The 3.
Is the numerator going to be easier to factor or the denominator?
The denominator.
The denominator is going to be much easier. We're going to have to factor them both. But the denominator is easier to factor because there's no number in front of the x squared other than 1. So what does the denominator factor to? Using your ring.
Squares. Nope.
No, it's not a difference of squares. Good catch on that one.
It's x minus 1 x plus.
There you go. So you're doing either your factor sum table or your rectangles. Some of you are able to factor this in your head already, which is wonderful. So now here's the thing. There is a good bet that you're going to have one of these two terms here when you factor this. So we got to factor this one. So I'm going to work on factoring this one over here. So we have 2x squared plus 5x minus 3. So I know that I'm going to have a binomial pair, right? What do I know about the signs? I should know what the signs are going to be.
Plus and minus.
It's going to be a plus and minus. Stella, why is there a plus and minus?
Because there's a plus and minus sometimes.
Yeah, because this is negative. Therefore, I have to be multiplying a negative and a positive together. All right, so what times what is 2x?
1 times 2. X.
1x.
1x times 2x. 1x times 2x. So we know we have to have a 2x, and we know we need to have a 1x. What times what is 3? 3 and a 1.
Negative 3.
So here's the thing. We need to have a middle term of 5. So if I do 2 times 1, I get 2. 1 times 3, I get 3. But am I going to add those products or subtract them? Those are going to be subtracted because one of these has to be negative. So 3 minus 2 is going to be 1. That doesn't work. So let's try this. What about 2 times 3?
6.
1 times 1? 1. 6 minus 1 is?
5.
5. Okay. So this is a positive, right? So that means the 2 times the 3, that means the 3 has to be positive, right?
So what is negative?
So these need to be in opposite parentheses, and then that means these two have to be in opposite parentheses. So we know the
2x plus 3.
so the plus 3 has to go here, and the 2x has to be in the opposite parentheses.
Minus.
That means the 1x goes here, the negative 1 goes here. And I can double check. I can multiply out the linear term. X times negative 1 is?
1x.
And 1x. 3 times 2, that's 6x. That's 5x. Excellent. So it works. So then I can write it out here. So we have x plus 3. Why did I write the x plus 3 second?
Because the 2x is more.
No, because you can cross out x plus 3 and x plus 3.
Oh, right, because they're the same. Oh, look at that. Excellent. So what is my final answer?
2x minus 1 over x minus 1.
You got it.
You guys sounded like robots.
Incidentally, the restrictions here, x cannot equal 1, and x cannot equal negative 3 in this case. So there you have 3 more problems to help you through your work.